Hi judges! Welcome to another segment of 1R Diwag Memorial High School Senior High School Math TV. Last time we were able to sketch the graph of the hyperbola. What if we're now asked a different question? So what if we're asked to get the fundamental rectangle of each hyperbola? So let us go back to what we have discussed from the previous discussions. When we say fundamental rectangle, it is also equal to the auxiliary rectangle. Okay? And when we say the auxiliary rectangle, therefore, we are asked to get its dimension. So, we're asked to get its dimensions. And what is the dimension of the fundamental rectangle or the auxiliary rectangle? So again, that is very simple. So that is just 2a by 2b. So why do we need to get the dimensions of the auxiliary rectangle? Always remember that this is very crucial in order for us to solve for the equation of the asymptotes of the hyperbola. Again, why? Because the diagonals of the auxiliary rectangle or the fundamental rectangle will serve as the asymptotes, and the intersection of the asymptotes will be our center. So I will repeat this again. If you are asked to get the dimensions or to give the dimensions of the fundamental rectangle, you are also asked to get the dimensions of the auxiliary rectangle. Why? Because it is needed so that you could write the equation of the asymptotes of the given hyperbola. Again, the equation or the formula that we will be using is just equal to 2a by 2b, or it is also equal to the vertical length by horizontal length, or by horizontal length by vertical length. Again, if that is the case, let us first draw the hyperbola. So this is horizontal hyperbola. And in horizontal hyperbola, these are your focus or the foci. This will be your vertices. This is your co-vertices. And when you're asked to get the vertical length, so this is our vertical length and this is our horizontal length. And we do not need the value of the foci or the C. Therefore, if that is the value from the center going to the vertices, that is A, this is A, this is also A, therefore A plus A is 2A. This side is equal to 2A. And the vertical side now, this vertical side, this is B, therefore the vertical side now would be 2B. And the dimensions of the rectangle would be 2A by 2B. So, not 2a by 2c, not 2b by 2c, but it is 2a by 2b. Again, that is through the length of the transverse by the length of the conjugate axis, which is 2a by 2b. I hope that it is clear that that is the dimension of the auxiliary rectangle or the fundamental rectangle. So let us now try to solve for the first one. So we have y squared over 4 minus x squared over 81 is equal to 1. Therefore, this takes the equation y squared over a squared minus x squared over b squared. The formula that we will be using is 2a by 2b, right? Therefore, if a squared is equal to 4, our a now is equal to plus minus 2. And if our b squared is equal to 81, therefore, our b now is equal to plus minus 9. Substituting the values of a and b to the formula 2a by 2b, this becomes 2 times 2 by 2 times 9. And we'll now be having 4 by 18. And this is the dimension of the auxiliary rectangle or the fundamental rectangle given the equation y squared over 4 minus x squared over 81 is equal to 1. How about for this one? Since 24 is positive, this side is positive, and this is the negative side, this is our a squared. Therefore, our a squared is equal to 24. Therefore, our a is equal to plus minus square root of 24, and our plus minus square root of 24 is also equal to plus minus 2 square root of 6. And we're now ready to solve for b squared, that is 9. Therefore, b is equal to plus minus 3. Using the formula 2a by 2b, we will now be having 2 times 2 square root of 6 by 2 times 3. 2 times 2 square root of 6, it becomes 4 square root of 6. 2 times 3 is 6. Therefore, this would be 4 square root of 6 by 6. And that is the dimension of the fundamental rectangle given the equation y minus 8 quantity squared over 24 minus x squared over 9 is equal to 1. How about for the third one? For the third one, therefore, our a squared is equal to 121, and our a now is equal to plus minus 11, because 11 times 11 is 121, and b squared is equal to 36. Therefore, b is equal to plus minus 6. Using the formula 2a by 2b, therefore, this is 2 times 11 by 2 times 6, that is 22 by 12. Again, 22 by 12 is the dimension of the fundamental rectangle of the given equations. So for the next one, we have x squared over 8 minus y plus 7 quantity squared over 100 is equal to 1. Therefore, our a squared is equal to 8, and our a is equal to plus minus square root of 8. But what is square root of 8? Therefore, a is equal to plus minus 2 square root of 2, because 8 is 4 times 2. So square root of 4 is 2. Okay? And b squared is equal to 100. Square root of 100 now is plus minus 10. Using the formula of the dimension 2a by 2b, we'll now be having 2 times a, which is 2 square root of 2 by 2 times b, which is 10. Therefore, this becomes 4 square root of 2 by, what is 2 times 10? That is 20. And this is the dimension of the fundamental rectangle given this equation. Let's move on for the next one. X minus 1 quantity squared over 1 minus y plus 3 quantity squared over 64 is equal to 1. Therefore, our a squared now is equal to 1, and our a would be plus minus 1. Our b squared is equal to 64, therefore our b is equal to plus minus 8. Using again the given dimension 2a by 2b, substituting the values of a and b, that is 2 times 1 by 2 times our b, which is 8. This is 2 by 16. And this would be the dimension of the fundamental rectangle of the given equation. Okay? For problem number 6, we have the quantity x minus 2 squared over 25 minus the quantity y minus 4 squared over 4 is equal to 1. Okay? So let us now get the value of a squared, or a squared would be 25. That a is equal to square root of 25, which is 5, or plus minus 5. For b squared, we have 4. Therefore, b is equal to the square root of 4 plus minus 2. We'll be having 2a by 2b. Therefore, substituting the values of a and b, this becomes 2 times 5 by 2 times 2. So that is 10 by 4. Therefore, that is the dimension of the fundamental rectangle, or the auxiliary rectangle, if we are given the equation x minus 2 quantity squared over 25 minus y minus 4 quantity squared over 4 is equal to 1. Again, the dimension of the auxiliary rectangle, or the fundamental rectangle, is just 2a by 2b. Okay, how about for this one? For this one, this now becomes a squared is equal to 16. Therefore, a is equal to plus minus 4. B squared is equal to 9. Therefore, b is equal to the square root of 9, which is plus minus 3. Using again the formula for the dimension 2a by 2b, substituting the values of a and b, that is 2 times 4 by 2 times what is our b? 3. Okay, so this becomes 8 by 6. 8 by 6 now is the dimension of the auxiliary rectangle given the equation y squared over 16 minus x squared over 9 is equal to 1. And for our last example, we have x squared over 9 minus y squared over 7 is equal to 1. We could say that a squared is equal to 9, therefore a is equal to plus minus 3. We also have b squared which is equal to 7, therefore b is equal to plus minus square root of 7. So substituting this for the dimension 2a by 2b, therefore this becomes 2 times 3 by 2 times square root of 7, that is 6 by 2 square root of 7. Again, let us try to review our answers so that we'll not be having an incorrect answer for this one. A squared 4, b, a is equal to plus minus 2, 2 times 2, 4. B squared 81, square root of 81, 9. 9 times 2, 18. So this is 4 by 18. For this one, square root of 24 is 2 square root of 6. Okay, 2 square root of 6. Therefore, that is 2 times 2 square root of 6, which is 4 square root of 6. B is 3. 2 times 3 is 6. Therefore, that is correct. For this one, we have 2a by 2b. 121 square root, that is 11 times 2, 22. 36 square root of 36, 6 times 2, 12. Therefore, that would be the dimension. Square root of 8 is 2 square root of 2 times 2 is 4 square root of 2. Square root of 100 is 10. 10 times 2 is 20. Therefore, that is correct. Square root of 1 is just 1. 2 times 1 is 2. Square root of 64 is 8. 8 times 2 is 16. Square root of 25 is 5. 5 times 2, 10. Square root of 4 is 2. 2 times 2, 4. This is correct. Square root of 16 is 4. 4 times 2, 8. Square root of 9 is 3. 3 times 2 is 6. Square root of 9 is 3. 3 times 2 is 6. Square root of 7. Square root of 7 times 2 is just 2 square root of 7. Therefore, all of our answers are correct. Again, this would be the dimensions of the fundamental rectangle, or what we call as the auxiliary rectangle. And the dimensions would just be the vertical length or the transverse axis by the conjugate axis. Again, that would be the dimensions of the fundamental rectangle given equations of the hyperbola. Once again, this is very easy. If you have questions, if you have suggestions, if you have comments regarding this video tutorial, do not hesitate to message me on Facebook, message me on Twitter or Instagram. And if you're not yet a subscriber, please do subscribe to my YouTube channel, and do not forget to hit the bell button so that you'll get notified whenever I post videos online. Again, I am Engineer Jod Edward Hernandez, saying that mathematics is always fun. Goodbye and God bless.